Graphing functions defined by radical expressions. So I'm given f of x equals square root of x plus 1. If we build ourselves an xy table, if I plug in 0, I get 0 square rooted, which is 0, plus 1 is 1. If I plug in 1, the square root of 1 is 1, plus 1 is 2. If I plug in 4, square root of 4 is 2, plus 1 is 3. If I plug in 9, square root of 9 is 3, plus 1 is 4. So we can go about putting these points on our coordinate system. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8. We have this x, y. And so first off, I put in 0, I get 1. If I put in 1, I get 2. If I put in 4, I get 3. If I put in 9, I get 4. So the function does something like this. Now here's something to note. If I put in negative 1, can I square root negative 1? No, so the function actually doesn't exist over here because we can't square root negative numbers. So this would be our graph. It would keep going on, slowly climbing. And if we wanted to talk about the domain of this function, it would be anything 0 and above. So we would say from 0 to infinity. The range, it starts here at 1 in the height and goes up. So we'd say from 1 to infinity. F of x equals the cube root of x minus 1. XY table. Putting 0 in, cube root of 0 is 0, minus 1. Put 1 in, cube root of 1 is 1, minus 1. Put negative 1 in, cube root of negative 1 is actually negative 1. You can cube root a negative. Minus 1 is negative 2. Cube root of 8 is 2, minus 1. Cube root of negative 8 is negative 2, minus 1 is negative 3. So if we go about putting these on our graph, we have this xy coordinate system, and 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. So 0 is negative 1. 1, 2, 3, 4, 5, 6. Should have made this a little longer, right? 7, 8. 1 is 0. So 1, 0. Negative 1, negative 2. Negative 1, negative 2. 8, 1. Just come out to 8. Go up to 1. Negative 8, negative 3. So this graph ends up taking on a shape kind of like this. So by building an XY table, we're able to graph these types of radical expressions or functions containing them.